right after we're talking about what's on this page, okay? So aldehydes and ketones are a class of organic compounds that have C double bond O's in them. They're often formed by oxidizing alcohols. Okay? And depending on the type of alcohol we oxidize, we can make either an aldehyde or a ketone, sort of just like we did. So here's an aldehyde, okay? R C double bond O H. So an aldehyde happens with that C double bond O at the end of the molecule. Okay? It has an H that sort of caps it off there. The difference between an aldehyde and a ketone is that we have a C double bond O with R groups on either side. Okay? That C double bond O is interior of the backbone. It's interior instead of terminal. So the backbone goes all the way through that from one end of one R to the end of the other R. Okay? So that's the main difference between aldehydes and ketones. Aldehydes are named just like alcohols, okay? Except we will end in al instead of ol. Okay? And the carbon that's part of the C double bond O, that counts as part of the backbone. In fact, that is always going to be carbon number 1 of the backbone. So a primary mistake that a lot of students make is to just sort of start on the branch over there. But the carbon that's double bonded, that counts as part of the carbon chain. Okay? So ideas for the name of the one there that I've numbered? Meth, eth, prop, bute is 1, 2, 3, 4. So what do you think? Eth? Eth? So it would just be ethane, right? Ethane. But it's not ethanol, it's ethanal. Okay. You have to pronounce it differently than ethanol. Ethanol is the OL alcohol. Ethanal is the aldehyde. Okay? So we have ethanal, then what? Propanal. Then what? How many carbons? 5? Pentanal? What about this one? See. It's kind of an interesting one, but it technically follows the same rule as what we've been doing here. Yeah, that is methanal. Absolutely. Unfortunately, nobody calls that one methanal. Everybody calls this formaldehyde. Okay. How about I put a red star by the common names that you should know? There's not going to be many of them, but yeah, I already put a star by that. Okay, so and we could have as many branches or whatevers as we wanted on these. We could have methyls, ethyls, chloros, T-butyls, whatever, but the numbering is going to start at the double bond. Okay? So we could very easily have 3-methyl pentanal, or 2,3-dimethyl pentanal, or 2,3,4,5 tetramethyl pentanal, or 2,2,3,3,4,4. Oh no, we can't have. Why can't we have methyls on 5? That would be a good sort of challenge problem for you. Why is there no such thing as 5-methyl pentanal? That would be a 6-carbon backbone. That would be hexanal. Okay? So think about that a little bit. But all right. So aldehydes You don't need a number to show where the double bond, where the CO double bond is, because that's always at the end, and that's always assumed to be carbon 1. Okay? Now, ketones, you do need a number because the double bond is interior, and especially if there are multiple places where that CO double bond could be, it's numbered that way. So both of these, that is a condensed structure and a line structure of a 3-carbon ketone. Okay? Our name is going to end in -one, just like ketone. Yep, 3 carbons ending in -one. That is propanone. This one does have an important common name, though. Anybody know the common name for this one? It's a molecule you've actually seen before. You've worked with it in the lab. Yeah, you use it to rinse things. Right? This is acetone. Okay. So that is one that you should know, but propanone is perfectly fine. Okay. Propanone. What about the next one? How many carbons? 4 carbons. Yep. Meth, eth, prop, butanone. Butanone requires no number, right? Why does butanone require no number? I mean, technically it would be 2 if we had a number there. Yeah, if it was on the other side, it would also be 2. We would number from the end closer to the functional group. Okay? So I could flip it either way. It's still 2-butanone. If the double bond was on the end, it wouldn't be butanone anymore. It would be, what's it called when the CO double bond is on the end? Look at the top of your page. It would be butanal. Okay? So an aldehyde and a ketone are very similar. Just has to do with whether the C double bond is at the end or in the interior. What about this one? Yep, needs a number now, because this double bond could be at any of these positions, right? This one, that one, or the middle one there. So we do need to number that one too. To what? Hexanone. Okay. So go back one page at the bottom. 1-butanol, when we oxidized it, what did we turn it into? What did 1-butanol become when it was oxidized? Butanal, right? Butanol. This is butanal. Right? If the OH was on the end, that is now an aldehyde. Okay. But 2-butanol, when it was oxidized, what did that become? Butanone. Butanone is a ketone. Okay. In our lab that we're going to do in a week and a half, we're going to have another way of sort of classifying those alcohols based on how many R groups are coming off of this C that's attached to the OH. The main difference here is that this C has just 1 carbon group coming from it, whereas this C right here has 2 carbon groups coming from it. Okay? So when there's 1 carbon group coming from it, we end up with an aldehyde after it's oxidized. 2 carbon groups coming from it like that, we end up with a ketone after it's been oxidized.